Hey everyone, today we're going to talk about the 10 properties of lipids. In fact, we're going to talk about 10 commandments of lipids. The 10 we're going to talk about are solubility, absorption of flavours, smoke point, flash point, emulsions, stabilisers, hydrogenation, oxidative rancidity, hydrolytic rancidity and plasticity. These features and properties of lipids enable lipids to do interesting things from a culinary perspective. The first property is, thou shalt not be soluble in water. Lipids are insoluble in water. They're organic solvents. So they're soluble in solvents such as ether and benzene or petrol. When you think of ether, you might be thinking about ether anesthesia. When in movies, a doctor or physician might douse a handkerchief with ether to render that person unconscious so they feel no pain in undergoing an operation. The second property of And thou shalt always remember to cover your food before putting it into the fridge, surrounded by strong smelling flavours. If you're going to make a Black Forest gateau, cover it up if it's near garlic butter. After melting point, 30 degrees to 40 degrees Celsius, we introduce the third commandment. Thou shalt decompose at 200 degrees Celsius if you are a solid fat, and thou shalt decompose at 250 degrees Celsius if you are an oil. Now basically what this means is that unrefined oils contain minerals, enzymes and compounds, and these don't play very well with heat and tend to be susceptible to rancidity. So things like good quality olive oil is best kept for drizzlings and dressings. However, this smoke point we're talking about, 200 degrees for fats and 250 degrees for oils, is desirable. It is what you want when you're cooking. So for instance, when you're making a stir fry using a wok, you do want a fat with a high smoking point. Now, after a certain temperature, depending on the fat and depending on how refined it is, a blue haze or smoke will start to come out from the surface of the fat. And this will give off a compound called acrolein, which is an acrid kind of smell. It's kind of when fat gets caught in your throat and in your eyes. What manufacturers do is they use industrial methods of bleaching and filtering and high temperature heat to extract any impurities in the fat and the oil, and then they can produce a vegetable oil which is going to have a higher smoke point and therefore can be heated to very, very high temperatures without this blue haze from emitting out of the oil. So the conclusion for smoke point is that when you're frying, choose oil with a high smoking point above 200 degrees Celsius. Keep butter for sautéing and other low temperature cooking methods. So this image illustrates what goes on in smoke point. You've got the blue haze, 200 degrees Celsius for solid fats, 250 degrees Celsius for oils. And then this is flash point, the red flame above there, 310 degrees Celsius, and these are just average temperatures. Remember, it does depend on the solid fat, it does depend on the oil, but you'll see that there is a higher smoke point for oils than there is for butter or other solid fats. The fourth commandment of lipids is thou shalt flash and spontaneously combust. And if you're cooking, you can use this property to your advantage. Flash points past 200 degrees Celsius or 400 degrees Fahrenheit are preferable for frying. Okay, you can see that ghee, which is a Indian clarified butter, it's got a higher concentrate of fat in it than butter does, because in butter there's quite a lot of milk solids and different it's a small amount of water as well, so that has a higher flash point. It's also higher in calories. And the fifth commandment of lipids is thou shalt not create a permanent emulsion without an emulsifier. So here's a few new words for you. In an emulsion, two immiscible liquids, that is, two liquids which don't normally dissolve in each other, are forced to do so, either temporarily or permanently with an emulsifier. So this creates something that's called a colloidal solution, which is when you've got one substance dispersed throughout another. So there's two types of emulsions we can have: a water in oil, which is W/0, or an oil in water. So with a water in oil emulsion, it's mostly oil. Oil in water, it's in the water, that means it's mostly water. We can get a temporary emulsion when we shake a jar of vinegar and oil together vigorously to create a French dressing. But after a short time, the two layers will separate and the oil will rise up to the top. So that's why a French dressing would be a temporary emulsion. This diagram shows an oil in water emulsion here on the left-hand side and a water in oil emulsion on the right-hand side. Now, in a permanent emulsion, an emulsifier lowers the surface tension between the oil and the water. An emulsifier has a hydrophilic head, and this means it's water-loving, it's hydrophilic. And then this water-loving head attaches itself to a water molecule. And then there's a hydrophobic tail, which swivels and turns around, kind of like a magnet almost. It goes into the oil molecule. And molecules of oil and water bound together with an emulsifier create permanent emulsions. Examples of naturally occurring emulsifiers in foods will be lecithin, which is a phospholipid present in egg yolk and soybeans. Lecithin is what helps to create an emulsion when you're making mayonnaise. Gluten in flour is an emulsifier. Casein in milk, it's a type of milk protein. Gums and pectin in plants. And glycerol monostearate, GMS, is a commercial emulsifier prepared from glycerol and fatty acids. Alginates are prepared from seaweed. Commandment number 6. Thou shalt prevent coalescence through the use of a stabiliser in an emulsion. Stabilisers are used to improve the stability of an emulsion by increasing its viscosity. Viscosity means the state of being thick, sticky, and semi-fluid in consistency. So, for instance, when you have a sauce and it cools, you could say that the fluid increases, the viscosity of the fluid increases upon cooling. And stabilisers are very closely related to emulsifiers. So starch is used in gravy and sauces, gelatin in ice cream, and gums stabilise yogurt. Commandment number 7. Thou shalt convert liquid fat into solid fat through a process called hydrogenation. This is a chemical process where you're going to get some vegetable oil and you're going to force hydrogen onto the double bond of the vegetable oil, which is mono or polyunsaturated fatty acids, using a nickel catalyst and heat and pressure. So what happens then is that the double bond is broken and the hydrogen can attach itself to the carbon chain. So you're causing an unsaturated fat to become a saturated fat. Commandment number 8. Whomsoever leaves food uncovered will subject that food to oxidative rancidity. In oxidative rancidity, oxygen reacts with carbon atoms of a double bond of an unsaturated chain. And really, oxidative rancidity has to do with incorrect storage of fats. It's the most common spoilage in lipids. Antioxidants such as vitamin C and vitamin E prevent rancidity. And oxidative rancidity will always happen, or most often happen, before hydrolytic rancidity, which is our next property. Commandment number 9. Whomsoever leaves food uncovered subjects fats to a breakdown by hydrolytic rancidity. Now, what does that mean? When you have your one fat molecule, and if there's quite a lot of enzymes and microorganisms and bacteria around, the fat molecule can get broken back down into its one glycerol and 3 fatty acids. And this causes an offensive smell. These free fatty acids roaming around is most unpleasant. What can contribute to this as well is the enzyme lipase, which is already in fat. Lipase is responsible for digestion of lipids as well in the body. But this can also hydrolyze the carbon chain. So you're adding back in that hydrogen that was lost in the condensation reaction with a little bit of oxygen. Everything's free again, and it's not to be advised. Also, antioxidants can play a good role in preventing hydrolytic rancidity as well. And finally, commandment number 10. Give shape to your bake by choosing the correct fat. Now, if you go to my video that I did on making sausage rolls, I made the most stupid error of experimenting with duck fat to make pastry. I wanted to incorporate that meaty flavour into the pastry for sausage rolls. It didn't work. And upon further investigation, this was because duck fat or dripping or suet aren't very plastic. Butter and margarine are ideal for baking because they're soft, they're pliable, they're malleable, and therefore they can give shape and structure, which makes them ideal for cake making. For example, in the creaming method, when you're creaming butter and sugar together, and in pastry making when you're rubbing fat into flour. How plastic a fat is determined by its degree of saturation. The more saturated fat there is, the more solid the fat is. So you kind of want, some unsaturated and some saturated fats together to get that correct plasticity feeling or result. So to test yourself, after reading through your textbook, listening to this video and reading the PowerPoint presentation, can you write out the properties of lipids? Double check your answers here. And a good exercise is, if you can speak the explanation out loud, you really know it then. If you can teach it, you will learn it. Here is your homework. You can see that explaining melting point, smoke point and flash point will come up at ordinary level. And the more chemistry orientated questions such as oxidative rancidity and hydrolytic rancidity come up at higher level. Also, to explain the role of emulsifiers in food production, giving the example of gums used in ice cream and so on, comes up at higher level. So that's it for today, and thank you for watching the video. As usual, any feedback or comments you have are very, very welcome. You can send me a message on Edmodo. Any suggestions or ideas to improve this method of teaching would be greatly appreciated. Thank you.